Okay, a suburban travels a distance of 3.6 kilometers between two stations in 3 minutes. Starting from rest, it accelerates uniformly until it reaches a speed limit of 90 kilometers an hour. If the train continues at this speed before it decelerates uniformly to rest, find the magnitude of deceleration is 3 times that of the acceleration of the train. Find the distance at which the train travels at the speed limit. Okay, so I suppose we're going to change these to meters and seconds for the drive at all. So 3.6 kilometers is 3,600 meters. 3 meters, 3 minutes is 180 seconds. 90 kilometers an hour is 90 multiplied by 1,000 divided by 3,600, which gets us 25 meters per second. Okay. Now, now that we're back to SI units, we can eventually start thinking about what we're doing here, right? So, so you decelerate a lot faster than you accelerate. So this would be just be 3, and then you spend a bit of time at constant velocity, and then you decelerate at 3 times the magnitude. Now, the deal with decelerating at 3 times the magnitude is that it takes 3 times less the time. So if it takes x amount of time to decelerate from here to here, it will take 3x to accelerate to the same speed, provided the same speed is it's 25 to 0 for both of them. So having 3 times the deceleration means 1/3 the time. Okay, so that's why you have 3x and x respectively. Now the whole every time added together adds up to 180. So we call this t2. So 3x plus t2 plus x equals 180. So that means t2 equals 180 minus 4x. Okay, so there's your 180 minus 4x here. Now, next thing we're going to do is we're going to say that the area under the graph is the total distance, and the total distance is 3,600 meters. Okay, so we're going to do area of each section. So I have 3x times 25 plus 25 times 180 minus 4x, and 25 times x. Okay, now I'm just going to throw, if you throw all of this in, and I mean do it properly as well, you're going to get minus 50x plus 4,500 equals 3,600. Okay, so just, you're all applied math students, do it out and you get that. Okay, and then bring over the what's it, the 4,500, and you get minus 900, and then you get x equals 18 seconds. Okay, so we know that x equals 18 seconds, which is brilliant. Now we can find out the time of the middle sector, which is going to be 180 minus 4 times 18, which is 108 seconds. Now 108 times 25 is 2,700 meters. And that's how much time, because distance equals speed multiplied by time, and what's it, it's going to be 18 times 25, which is 2,700 meters. Okay, and that was worth, I think it was worth 10 marks. Right. So next thing we're going to go for part B. A car moving along a straight level road passes traffic light with speed u meters per second and constant acceleration f meters per second squared. Oh, sorry. No. I'm on part two. Sorry, my fault. Find the shortest time it takes the train to travel from rest to rest between two stations if there's no speed limit, assuming the acceleration and deceleration remain the same. So we're gonna delete. We're gonna delete all of that, and we're gonna delete you because there is no constant acceleration phase. We're gonna delete all this, and we're gonna bring you to here, and there's no need for you anymore. Okay, and we're gonna rub out everything. Now, in this case, we have a. In this case, we have a what's called a V. V is the speed limit, and you start off at 0. And there's two areas, and both areas combined equals 3,600 meters. Okay, so that's all okay. Now, the other thing we got to remember. I'm trying to see now. Rest. If there's no such speed limit, acceleration and deceleration are the same. Okay, so once again, if the acceleration is 3 times the other one of the times will be 3x and the other time will be x. Okay, and we're assuming that the acceleration and deceleration remain unchanged. Now, I suppose in the last question we could have actually found out what the deceleration and acceleration were. So if we remember the last question, so I sort of jumped into this question without really extracting all the information from the last part, is that we had x was 18, so that was 108 seconds, that's 18, and this one here was 54. Okay, because that was 3x, x, and 180 minus 4x. And so it took 54 seconds to reach a speed of 25 meters per second. Now, a really cheap way of doing this, most of you probably don't remember, is tan of the angle gives you the acceleration. So tan x will give us 25 over 54. Right, and that's your acceleration. And your deceleration, which is 3 times bigger, is also tan of the angle, except negative. So tan y would be 25 over 18. So your deceleration is minus 25 over 18. Okay, so that's cool. So what we have there is the acceleration and deceleration. Okay, so that's very cool. Now, we could also try and think of it like this as well. Alright? So if this is T1 and this is T2, and we all know that T1 is 3 times T2, that's no bother whatsoever, right? And we know that that's V. We also know that tan x is phi over T1, and phi over T1 is 25 over 54. And then in turn, what that will mean is that we can get V in terms of T1, or T1 in terms of V. So let's get T1 in terms of V. So T1 equals 54V over 25. Now likewise, time has to be positive, and tan y is phi over T2, which is 25 over 18. Now we're talking about magnitude, not. Remember, time has to be positive at the end of the day. So T2 is 18V over 25. And that's exactly what we thought, that T1 is 3 times as long as T2, which is perfect, alright? Now next thing we're going to do is we're going to get the area of both sections. So we can get the area of the area of the green section here, and then add it on to the area of the yellow section, both triangles, and we can find out that the answer is 3,600. Alright, and that's what we intend to do. So it's going to be a half your base is T1 times V, so it's going to be half V T1, but we know what T1 is. T1 is 54V over 25, and T2, it's a half V T2, and we know what T2 is as well, so a half V, and T2 is 18V over 25, and that all equals 3,600. Okay, so then when you add the two of them together, you're going to get 72V squared over 50 equals 3,600. When you move everything around, you should get V squared equals 2,500, and V therefore equals 50. Now it does specify that it wants the shortest time, so I haven't got that yet. So I'm going to have to sub in 50 into my T1 and T2 values. So here we are. So I'm just going to sub in 50 and sub in 50 here, and get both values. The first value is 108, second value is 1/3 of that, which is 36. Add them both together and you get 144 seconds. Alright, so that is question linear 1A.